Good morning, Richa.
Good morning, sir.
Good morning. Good morning, Smith.
Good morning, sir.
You are in Ahmedabad? You all are in Ahmedabad or
No,
somewhere
sir.
else?
Patan. Patan.
You are in Patan.
Yes, sir.
Oh, and what about Richa?
Sir from Ahmedabad.
Ahmedabad. Okay.
Sir, if you remember, like we have met like 4 times in these 2 years. If you see, you'll recognize me. I don't know if you know me.
Okay.
So we have you were the guest in KK Shah Jarotwala for the oral and poster presentations.
Okay. So you got the prize or what?
Yeah, like yes, I got that, and I was under the guidance of Unnati ma'am also in the Science Excellence in 2019, where you were the judge again.
Okay. Okay. Can you just switch on your camera? I'll just see and try to
Okay.
recognize you. Whether I've seen you. Okay. Yes. 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 Yes.
Yeah.
Correct, correct, correct. Yes, I can recognize. Yes, now I can recognize. Good. Acha, acha. So you are Richa.
Yeah,
Good.
from KK Shah.
So, okay, good. So you know me since last 2 years now, almost. Okay.
Yes, from last 3 years.
3 years. Three
Yeah.
years. Okay. Good. Very good. Very good. And how do you find now coming over from KK Shah to School of Science? Though it is totally online, we don't get to meet, but still, I mean, how do you rate it?
Yeah,
Be
so,
honest.
so yeah, very frankly, like KK Shah Jarotwala had like very good management of teaching, studies, activities, and everything. I feel though it was offline, it has to be that way. But here, I don't find that management of like taking exams, providing internal marks, like the examination we give, we are not given those internal marks also. So
Okay, okay.
those are some
So,
problems, like small things.
Rija, I understand. This would be a problem for
Yeah.
all the students, because see, I fully agree with what you say, but the thing is, you just imagine, Richa, we
Mm.
started in December, somewhere in last week of
Yeah.
December,
21st
and
December.
21st December we started, and now we have just completed about 4 months and few days, and we are almost in the halfway in second semester, and
Yeah.
everything is going online and with this corona thing. So general procedure when we are in offline, we always display these marks. But the
Yes.
problem is where to display. So it cannot be displayed online now. So this is this is what you felt, that the management kind of a thing is not correct.
Yeah.
I understand to some extent it is affected because of this thing, pandemic thing, but otherwise marks are shared and you get to discuss your problems with the faculties in person anytime during class. So those things are missing. I understand that one-on-one interaction is missing, but that cannot be held now. And I
Yes.
possibly so
And sir,
that,
during those online lectures also, if like whoever wants to study can turn on their videos and can interact now, so that can also be a advantage to us, and even faculties can know us. Here, what
sure,
happens
sure.
whenever
Huh.
whenever we meet them or for any kind of problem we reach to them, they don't know us either.
They
They don't know even that who are they, like that way. So if this can be solved, it is also like that's an option for this also, if we can
yes.
switch on our camera and studying. So
Yes, yes. See, I have no problems. I have no problems if you switch on your cameras. Absolutely no issues if that is the case. And secondly, if you have any problem, I always encourage students to speak up and share their thoughts. So I mean, this is what I promote, and I welcome students coming out and they are forthright in asking something. I repeatedly ask, and if that is the case, that you can. It is not that we don't want to see your face. I mean, you can always switch on your camera when you are asking. I have absolutely no issues with that. Absolutely no issues with that. And uh, otherwise we don't have anything, like as far as personally, if I going to say, I don't have any issues if somebody switches on the camera and asks something. I mean, this is most welcome. That is not a problem at all. But still, if you want that, I'm open to that. That is not an issue, because until and unless you people come out with something, nothing is going to. It cannot be a one-sided affair. I am just speaking and you are just listening. It will not serve the purpose. So it is better that you also come up with some questions. See, I'll tell you, in PG, what is best is that you come up with set of questions and discuss. If there are 10-12 questions in a lecture, I would say that would be more useful, because if you come prepared little bit, so it will be easier. It will be, it will be easier for everyone, like rather to, because if you have 10-12 questions, I think if that is discussed among students, I know every student doesn't want to speak up, but then whosoever wants to do it, I think it will be useful for others as well. So this is what I feel, the this thing should be there. It should not be a one person speaking, the others are listening for 1 hour and that's it. That should not be the case. And this is what I do when we teach. At least what I think of while teaching is that during class you are supposed to interact and you should interact. And from that is what I would say, Richard, and for others as well. But good that you spoke up. Yes, spoke regarding this. That is good, and that is what I expect from students. See, in semester 3 and semester 4, I have a relatively small group of 45 students. So practically, I know everybody now, because that's a small group, and they know what is happening in the semester 1 and semester 2. So they are well equipped to handle the situation in SEM3 and SEM4, and with the small group it is much easier for me and for them to interact. So I remember the names also. I remember them. I can see them. I can talk to them. Even yesterday evening, I had a small meeting with them for SEM4. So that is possible there. I mean, that is more feasible there. But here, because of 160 odd students, I don't know, some of them are reluctant to speak, or maybe they are a little bit shy. I understand that, but still, those who really want to share, they are free to share. That is what I would say, Richard, and others, to others as well. Okay. So I'll just I'll just share my screen now. And that is what I have done. I mean, like, I keep on giving some questions looking at the slides. It is only intended that you get some idea about how am I going to ask from this presentation. This presentation will be shared with you, no problem, once this unit is over. Maybe next week, and I think I'll be sharing this unit as well. So I think you all can read also, and at the same time, if you come across while you watch this, what you do is you also can come up with a question. Okay, sir, can we make a question like this? So that will be also be useful for you and for others, for everyone. Okay. Now I'll just start where I left. Now you tell me where I left. Can anybody tell me?
Sir, this was done.
Done.
Right.
Okay.
Counters.
Okay. This was also done, I suppose. I think I'm little ahead in HPP as compared to VS, slightly ahead, 3-4 slides
Yeah,
ahead.
this was done.
So see, I'll just give you the gist of what counter current extraction is. See, first thing, what I would say here is that when you compare it with liquid extraction, that is a single extraction. There you don't do multiple extractions like this. Here you do multiple extractions, and with multiple extractions, it has been demonstrated through Craig's countercurrent extraction system, that one can separate those no, those substances which have very similar distribution ratio as well. Of course, in that case, we need to have large number of Craig's tubes together in sequence, uh, and perhaps the distribution would occur somewhere maybe in the 200th, or I don't know where it would occur. Separation might take place, but to separate two which are having markedly different partition coefficients, I think liquid extraction would be adequate. But those molecules or those substances or those solutes which have intermediate, I mean, distribution ratios, there and where they have very similar distribution ratios, there Craig's countercurrent extraction would have a vital role to play. Having said that, if you are now in 2020, you don't need countercurrent extraction because you have a much superior technique which we call as chromatography, which is our second unit. But at the same time, there was at some point of time in the history of separation, uh, in the late 50s, countercurrent extraction was one of the sought after technique to separate such compounds. So this is the whole essence of introducing you to this technique, and the advantages, and these are some of the slides which just give you an idea about how things happen in the Craig's apparatus. That means over a period of time, in the first extraction, in the second extraction, what used to happen, keeping the distribution ratios constant throughout. That is a constant thing. And as far as the principles, some of the principles of countercurrent extractions are concerned, separation of solids with similar distribution with large number of Craig's. So this is important. Separation of solids with similar distribution ratios, which is not possible to. I'm talking about, when I say similar distribution ratio, means under all the conditions you set, still if they cannot be separated, then we say that they have a very similar distribution under the all the optimized conditions. So this is one such thing important with CCE. And it, of course, it involves successive extractions with fresh solvent for complex mixtures. Uh, See, small molecules, separation of small molecules is relatively much easier. But when you work with large molecules like vitamins and proteins and hormones and polypeptides, etc., now this cannot be done by a simple liquid extraction. So there, at that point of time, when you did not have anything, then this technique was of had prominence in those times. So it involves successive extractions with fresh solvents that we discussed. And there were about hundreds of tubes in series which were attached in those times to have to separate such complex mixtures. And these are some of the applications which one can associate with countercurrent extraction. Separation of mixtures, as I said, vitamins, polypeptides, nucleic acids, hormones, and even proteins. And then it was at that time in pharmaceutical industry for purification of pharmaceutical preparation. Now if you look at the current scenario, you have preparative HPLC. You have preparative HPLC where you can do any kind of separation, even in small amounts and even in large amounts. So when at that time when people wanted, when they prepare some pharmaceutical preparations and they wanted to purify it, they used to use countercurrent extraction at that time. And for preparative purpose, now this is a thing which I'll speak a little bit. For preparative purpose means, what does preparative purpose means? Now this is, see, there are in analytical science there are two ways you can use an instrument, two ways in which you can instrument. Either you can use an instrument for very small amounts of samples, very small amounts of sample. But what happens is, fine, you have done your separation with the techniques or tools or instruments available with us as of now. But these all are essentially analytical techniques, not preparative techniques. When I say analytical techniques, that means they can take up very small amounts of your samples, very small amounts. Now, just have an example. Look at HPLC. It will take only 10 microliters. You understand, 10 microliters. 1 ml is 1000 microliters. And when you say 10 microliters, it would be 0.01 ml. So when even GC takes 1 to 3 nanograms of your substance. So now what you find in separation science is that there are basically the techniques are divided into two. One is the analytical techniques and the other are known as preparative techniques. When we talk about analytical techniques, they take up very small volumes or amounts of substances to be analyzed. And when we look at preparative purposes, for preparative instrumentation or techniques or tools, we talk about milligrams and grams. Milligrams and grams. See, grams is something, a very big when you compare it with micrograms. So they can do separation in milligrams to grams. And in doing this, a very well-known technique which you will read possibly in next year if you are in analytical, and that, okay, you cannot be, you are in HPP. So what you read in the, what you understand in next year is something called preparative HPLC. जो भी आप HPLC के नाम सुनते हो ना, HPLC, people say HPLC, those, that is actually analytical HPLC. That is not preparative HPLC. Preparative HPLC is a different setup, is a different instrument where you can separate in gram quantities. Even large columns are being used where you can go up to few kilograms as well. But that is a huge affair. I mean, it takes up the entire building in having separations in amount in kgs. But grams, yes, lab scale you can do using preparative HPLC. So that is what, just try to understand that in those times, 70 years back, 60, 70 years back, people used to use this technique for preparative separations. I mean, large quantities of separation, which was not possible uh, with your conventional liquid extraction. So that is, so these are some of the applications, and I think this much idea about Craig's countercurrent extraction is enough for you at this stage to appreciate this technique, though it is not applicable anymore. You don't come across such any equipment anymore, but since because of the advent of chromatographic techniques. Any questions up till now? Or if you can think of any MCQ. No answer? Hello?
Yes, sir.
Yes, sir. Okay, good, finally. Just a minute. Now I'll just see the 35 today. So, okay, so you have understood. All of a sudden, I find that you people have gone silent. Uh, I think since last 1 week. Prior to that, you were active and you used to respond. But anyways, there must be some problem. Okay, the other extraction process which also warrants mention here is accelerated extraction. अब क्या होता है, I'll just speak little bit in Hindi for the benefit of others. जब हम कोई एक्सट्रैक्शन करते हैं तब हम इफिशिएंसी पे ध्यान देते हैं, मतलब कितना ज्यादा सा एक्सट्रैक्शन हो सकता है, ज्यादा से ज्यादा हम कर सकते हैं. लेकिन एक और भी चीज होती है एनालिटिकल साइंस में, टाइम. कितने ज्यादा से ज्यादा हम एक्सट्रैक्शन कर सकते हैं, कितने कम से कम टाइम में. तो उसको ध्यान में रखते हुए, there is a technique or a process known as accelerated extraction, where you accelerate the extraction process so that time is saved, and you can do, when time is saved, energy is saved, so on and so forth, and the cost can be reduced. So those aspects are also part of analytical science when we go for any method or when we go for any extraction. So accelerated solvent extraction is a technique for efficient extraction of analytes from solid sample matrix into a solvent. Now this is primarily used for extracting from a solid sample, and we know by now that solid sample is the most toughest sample to work with, in the sense that it is highly heterogeneous. It's a different phase altogether, and to bring it into a liquid state in a solvent, uh, it takes time. Efficiency, yes, but it takes time. So therefore, if we can do this entire process of extraction in a closed system, in a closed vessel, possibly we can serve two purposes. One, we can save time. Second, we can eliminate the possibility of losing any volatile substances which are present in that solid sample. So it is not that all solid samples will have volatile compounds. No, but there could be some compounds, some samples which have volatile compounds. So one can preserve the integrity of the sample. At the same time, one can considerably reduce the time for analysis, and therefore accelerated extraction deserves a mention, that it can be done by this extraction process in a closed system. What it does, the high pressure in a closed system allows heating above the boiling point. Now this is which is not possible when you heat something under the normal conditions at normal pressure. You are unable to do that because it's an open system. And when you boil something, it boils at the temperature of the solvent. Because of the latent heat, it doesn't go beyond that boiling point of that solvent system. So with a closed system, you have high pressure, which allows heating above the boiling point. First thing, and second thing, high temperature, of course, which can be attained due to high pressure, accelerates the dissolution of the analytes. It further accelerates the dissolution. That means it saves considerable time. So both time of extraction and volume of solvent needed, this is also important. Volume of solvent needed is greatly reduced over atmospheric extraction, which we conventionally do. So what could be surmised from accelerated extraction is that it serves three purposes. It saves time, it saves volume of solvent needed while maintaining the efficiency. So these two things are very vital. And of course, once you do that, the cost will also be significantly reduced for analysis. And of course, maintaining the efficiency. And at the same time, you don't lose the sample integrity or you don't lose any volatile compound. So these are the salient features of accelerated extraction. So now if I can make a MCQ out of it, out of this discussion, what it would be like. Can anybody help me in making a MCQ from what we just understood in this slide? I want your participation today. Your active participation today. Still no voice? Early morning? Hello?
Sir, from the first line,
Yes.
accelerated solvent extraction is a technique for efficient
Okay.
extraction of analytes from dash sample matrix into a solvent. So that's solid, liquid,
Okay.
gaseous or
ठीक है, लिखो, अब लिखो. I am happy कि थोड़ा आपका participation होना चाहिए. And so the question is like this, what Risha just mentioned. uh, Accelerated solvent extraction is a technique for efficient extraction of analytes from dash sample matrix. This is the question now. It is very easy. You can look in the slide and write. And then you can write the options as well. So this is your, and then you can write your, then you can write your options. So options can be liquid, gas, solid, or supercritical fluid. लिख लिया? लकी लिदू?
yes, sir.
गुड गुड. भैया दूसरे भी बोलो भैया, ये तो ऐसा हो रहा है कि मैं जबरदस्ती बुलवा रहा हूँ आपसे. आई वांट भैया, कोई दिखता ही नहीं. स्मिथ, तुम तो सबसे पहले आ जाते हो भाई, कुछ तो बोलो. ये सब ऑन करके चले गए हैं क्या, या मेरे पढ़ाने में कुछ इंटरेस्ट नहीं, मतलब is there any problem with me? Then I'll try to rectify that. ये भी नहीं बोलते.
No, sir.
might be network problem.
अच्छा नेटवर्क
No,
प्रॉब्लम।
sir.
नो सर, चलो बढ़िया है, एटलीस्ट चलो तुमने इतना तो कहा, नो यस तो बोल रहे हो। ओके, तो देखो ये एक सवाल बन गया था, ठीक है ना। अभी अभी ऋचा ने कुछ हमको गाइड किया और हमने एक सवाल बन गया। और इसी तरीके से आप लोगों को इसमें थोड़े से ये मेहनत करके बनाना है। एंड थिंग्स आर वेरी सिंपल, यू सी, ऑनेस्टली आई टेल यू, थिंग्स आर सिंपल हियर। You just need to be little bit more, focused when you try to understand, and then you will have a list of MCQs. I do not have a single MCQ with me, honestly. When I teach, I just think over what I am teaching, and I just try to frame something. That is what I do, and that is why I always ask students that you should share it with me, because I forget what I delivered here. Even I forget what I've taught you today, and maybe tomorrow I'm going to do the same thing with GIA students. So maybe I'll be totally in a different mood, so I'll be talking something else. But at least I'll be having some common things, so that you both are equally benefited. ठीक है, अब हम दूसरे चीज में जाते हैं, एंड दैट इज अनदर एक्सट्रैक्शन। सी दीज आर ऑल, है ना, दीज जो मैं आपसे बात कर रहा हूँ कि ये एक्सट्रैक्शन वो एक्सट्रैक्शन, माइक्रोवेव एक्सट्रैक्शन इज वन ऑफ द ग्रीन अप्रोच इन सेपरेशन साइंस, just like supercritical fluid extraction, which you will read maybe next year. But this year, microwave extraction, this is a green approach in analytical methodology. So this is a very important, extraction process, and for which I have made about 5, 7 slides, 8 slides, for you to make you understand what is it. देखिए, हम किसी भी चीज को एक्सट्रैक्शन करना होता है, जनरली सॉलिड्स के साथ ही ये प्रॉब्लम होती है। लिक्विड तो आसानी से मिल जाते हैं, काफ़ी कुछ लिक्विड्स में आसानी होती है, बट सॉलिड्स के अंदर एक्सट्रैक्शन करना इज वेरी डिफिकल्ट, इट्स वेरी टफ। सो उसमें अगर हमें टाइम बचाना है और एनर्जी बचानी है, कॉस्ट बचानी है, तो हमको कुछ मेजर्स लेने होते हैं, जैसे हमने अभी देखा एक्सेलरेटर एक्सट्रैक्शन में। तो उसी तरीके से हम एक एनर्जी सोर्स ले लेते हैं। अभी तक तो हम बर्नर से हीट करते थे या हीटिंग मेंटल में हीट करते थे, लेकिन अब हम उसको हीट करेंगे माइक्रोवेव से। और वो भी डायरेक्टली नहीं करते, हम सॉल्वेंट को हीट अप करते हैं, फिर ग्रेजुअली हम करते हैं। देखिए, कन्वेंशनल जब हम हीटिंग करते हैं बर्नर में, तो इट इज एन ओपन सिस्टम एंड हीट एंड मास ट्रांसफर, जो हीट ट्रांसफर होती है सैंपल को, और जो मास ट्रांसफर होता है सैंपल में से सॉल्यूशन के अंदर, ये बड़ा ही अलग तरीके से होता है। इसीलिए कन्वेंशनल हीटिंग या कन्वेंशनल एक्सट्रैक्शन वो बहुत समय लेता है, और उसकी इफिशिएंसी भी इतनी नहीं हो पाती है, और बिकॉज इट्स एन ओपन सिस्टम it becomes hazardous as well. Now in microwave assisted extraction, हम instead of conventional heating, बर्नर से जो हीट करते हैं, we heat with microwave energy of the order of, आपको पता है इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम में जब हम लेते हैं, उसमें वेरी लो एनर्जी है कंपेयर टू अदर रीजन्स ऑफ इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम लाइक यूवी, विजिबल, IR, बाद में माइक्रोवेव आता है। तो माइक्रोवेव एनर्जी से हम सैंपल को एक्सट्रैक्ट करते हैं, हीट करते हैं, और वो हीट डायरेक्ट नहीं होती, इनडायरेक्ट होती है। हम सॉलिड को हीट नहीं कर पाते, लेकिन सॉल्वेंट, अगर उसमें हम सॉल्वेंट डाल देते हैं, कोई सॉल्वेंट डाल देते हैं, सुटेबल सॉल्वेंट डाल देते हैं, तो हीट ट्रांसफर हो जाती है। और उसका हीट ट्रांसफर होने का एक प्रोसेस है, एक तरीका है, एंड विद द रिजल्ट द एफिशिएंसी of extraction is much higher. The time required is much lower. considerable amount of energy is saved. And it is said that even toughest samples can be extracted with microwave assisted extraction. So these are some perceived advantages of microwave extraction over conventional extraction. अब इसमें होता क्या है, मैं कुछ पढ़ता हूं so that आप थोड़ा इसमें भी आप ध्यान दे दीजिए स्लाइड में. The analyte compounds are again partitioned from the sample matrix into the solvent. See, अब इसमें क्या हुआ, जब हमने solvent डाला, there are two phases. One is solid phase, the other is liquid phase. That is solvent. And solid phase is your sample. अब sample के अंदर से जो analyte है, that will be has to come out now. So that will be partitioned between the solid phase and the liquid phase. ये बड़ा यूनिक चीज है जो आप liquid extraction में नहीं देखते हो. That means there has to be some equilibrium there is also. क्योंकि ये closed system होता है, it is similar to accelerated extraction, but the energy source is different. Here it is microwave energy. In accelerated extraction, you had conventional energy sources. The kinetics of extraction is affected by the temperature and the choice of solvent or solvent mixture. This is important. देखिए, temperature तो बढ़ेगा, heating तो होगी when you give microwave energy to your sample in a suitable solvent, but the choice of solvent or the mixture of solvent which you use for extraction is very critical. ये चीज जनरली आप एनकाउंटर नहीं करते हो कन्वेंशनल में. कन्वेंशनल में आपको कोई चीज डाइजेस्ट करनी है, आप एसिड डाल देते हो, कभी एल्कली डाल देते हो, फ्यूजन कर लेते हो, फिर एसिड में डिसॉल्व कर लेते हो सॉलिड को, या फिर सिंपल एक ऑक्सीडाइजिंग मिक्सचर बना लेते हो HCl और नाइट्रिक एसिड का, जिसको एक्वारिजिया कहते हैं 1:3 रेशियो में, और उसमें डाइजेस्ट कर लेते हो. ये जनरल टेंडेंसी होती है, एक कॉमन जो हम अभी तक पढ़ते आए हैं. लेकिन वही काम हम माइक्रोवेव में करना चाहते हैं, नॉट विद द हेल्प ऑफ एन एसिड बट विद द हेल्प ऑफ solvent systems. Solvent or solvent system, one can take a mixture of the solvent system. So atmospheric heating for extraction is limited to the boiling point of the solvent. At the same time, heating और भी efficiently होगी, closed system है. So solvent के जो temperature उसके ऊपर भी heating होगी because it's a closed system. So these are some of the advantages of microwave assisted extraction. I'll be dealing this in depth today. How you can understand this entire process. Closed vessel temperatures at 175 psg, this is pressure, typically reaches on the order of 150 degrees centigrade. At that high pressure, one can reach because it can reach you can reach a temperature of about 150 degrees centigrade in closed vessels, compared with boiling points of 50 to 80 डिग्री सेंटीग्रेड for common solvents used. मतलब हम 80 डिग्री सेंटीग्रेड को भी 150 बना सकते हैं. मतलब ये पॉसिबिलिटी रहती है when we heat with solvents under a closed system in microwave extraction. अब इसमें एक और चीज है कि जैसे मैंने आपको बताया कि solvent selection of solvent is very important. Hexane is microwave transparent. इसका मतलब है कि उसको कुछ नहीं होता, उसको कुछ भी नहीं होता. लेकिन जैसे मैंने बताया, दिस इज नॉट अ डायरेक्ट प्रोसेस, दिस इज एन इनडायरेक्ट प्रोसेस. द हीट एनर्जी इज फर्स्ट ट्रांसफर्ड टू द सॉल्वेंट एंड देन सॉल्वेंट डज समथिंग विद दिस सॉलिड मैट्रिक्स एंड देन इट अफोर्ड्स एक्सट्रैक्शन. सो क्लोज वेसल में जो हम लेते हैं इसमें ऑफ कोर्स उसमें माइक्रोवेव, दैट शुड बी माइक्रोवेव ट्रांसपेरेंट, क्योंकि अगर वो एनर्जी लेने लगेगा तो एनर्जी कम जा पाएगी सैंपल में. जो हम कन्वेंशनली देखते हैं कि हमारा वेसल ही गर्म हो जाता है, क्योंकि वो भी गर्म हो जाता है, अंदर सॉल्वेंट भी गर्म हो जाता है और अंदर सब कुछ गर्म हो जाता है. सो it is essential that we use a suitable solvent system in a closed system, and the vessel should also be transparent to microwaves or microwave energy. And the body of the vessel is made up of polyethylamide. This is for academic purpose with a perfluoroalkyl liner. This is okay. This is for academic purpose. Now, uh, what is the fundamental difference between conventional heating or conventional extraction and microwave extraction? This is what we can surmise from why microwave extraction is more efficient as compared to conventional extraction. The first and foremost, in conventional extraction, what we find is heat transfer is from outside to inside, and then mass transfer occurs from inside to outside. So these two phenomena, heat transfer and mass transfer, they occur in opposite direction. So they constantly cancel each other, and therefore it takes significant amount of time in conventional extraction. On the other hand, when we look at microwave assisted extraction, the heat is distributed volumetrically inside the irradiated medium with microwave energy. This is important. There it is directly transferred from the burner to the solvent system. Here it is volumetrically, that means from all the sides equally. It is just, there is a flux of energy, there is a flux of microwave energy inside the vessel. So the heat is distributed volumetrically in the entire system. This is one major difference. And mass transfer occurs by diffusion, which is not the case in conventional extraction. And fortunately, it is said that, and it has been observed that heat transfer and mass transfer occur in the same direction. They complement each other. And therefore, microwave extraction has much higher efficiency, as well as it takes much less time, as well as when I say efficiency, means it does what it is intended to do. It doesn't do anything beyond what is intended to do, which happens in conventional extraction. So microwave assisted extraction is a technique in which heat transfer and mass transfer complement each other, and thereby the efficiency of extraction is significantly higher in microwave extraction as compared to conventional extraction. So from this, one can have a MCQ again. Why microwave assisted extraction is or has higher efficiency than conventional extraction? Why microwave assisted extraction has higher efficiency than conventional extraction? Really clear? Again gone into silent mode. हेलो, फिर से चले गए?
यस सर।
चलो भैया, हो तो कुछ लोग तो हो. हाँ, अच्छा, जय किशन नहीं दिखते. जय किशन इज देयर? हेलो? No, I don't find him because I think last time Richa, Jay Kishan and few others used to ask. Anyways, लिख लिया. अब इसके आंसर भी लिख लो भैया. अब तो तुम लिखवाओगे तो लिख लो. आंसर्स ऑप्शंस लिखो. Heat and mass transfer in the same direction. Heat and mass transfer in the same direction. Heat and mass transfer in the opposite direction. Then you have only heat transfer, and then you have only mass transfer. तो ऑप्शन कौन सा हुआ? A, B, C, D. तो which is the answer now? फिर से चले गए. अच्छा अच्छा भैया ये बता दो, मतलब आई एम जस्ट क्यूरियस टू नो दैट this happens with me only or it happens with others also, मतलब when they are there in other lectures?
Sir, in every lecture.
Okay भैया, I thought कि all of a sudden something went wrong with me, that you have just stopped responding, so I thought I should clarify this first कि अगर मेरे में कुछ कमी है तो मैं मेरे में सुधार लाऊं कि ये सब में हो रहा है. एंड टुडे आई फाइंड ओनली 35 36. ये क्या चक्कर है, मतलब जनरली कितना होता है, कुछ आइडिया है कितना होता है जनरली?
54 तक तो होता है.
कितना होता है?
54 55.
54 55 भी होता है?
Yeah, but sir, these days this ratio is only maintained 35 38.
अच्छा, ऐसा रहता है मतलब.
Yeah.
The only thing which worries me is that this figure is not even half of what are present in SEM2. There are 80 and there are 80 and I find only 35, so it is less than 50%. That is what worries me कि बाद में करेंगे कैसे, क्या होगा. सी आप लोगों का देखिए, आपको अभी मैं बता दूं कि there will be your internals most likely by the end of May possibly, so you need to prepare yourself accordingly कि आपका जो ये होगा ये it would be somewhere in the last week of May. So I'm just informing you, the dates are not announced as yet, but it will be done maybe after 10-15 days, when we will be having your internal exams for practicals and theory. And by that time, hopefully, two units will be at least completed in all 4 papers. So we'll be in a position to frame questions out of those 2 units. So this was it. So okay, I'll again go back to the presentation. Now these are certain things which I would like to just share with you and hopefully make you understand whether if to make you rather understand how this process occurs. As I said, this is not a direct process. This is a very gradual process. But gradual doesn't mean it takes time. It takes place very fast. But these are the possible steps for extraction in MAE, micro-assisted extraction. There are 3 different steps: the equilibrium phase, the intermediary phase, and the last phase where diffusion occurs. So as I said, the essential difference between the conventional extraction and this is, apart from heat and mass transfer in the same direction, the diffusion, and that occurs very fast. Now in the equilibrium phase, the phenomenon of solubilization and partition intervene. That means they both start to act at the equilibrium phase, in which the substrate is removed from the outer surface of the particle at an approximately constant velocity. देखो, जब ये liquid जाएगा तो liquid will be first in contact with the outer surface of the sample. So there will be a phenomenon of solubilization and partition, solid liquid partition there. The second phase would be intermediate transition phase to diffusion. That means just before diffusion, that phase, transition phase, that is known as intermediary transition, the resistance to mass transfer begins to appear in the solid liquid interface. Now this is important. एक फेज लिक्विड है, एक फेज सॉलिड है। तो जो सॉलिड में से जो एनालाइट है, जो सॉलिड है, वो लिक्विड में जाने के लिए हेजिटेट करेगा। जब जब ये हेजिटेट करेगा, सो देर इज अ रेजिस्टेंस डेवलपिंग across this, the two phases solid and liquid for efficient mass transfer, and begins to appear in the liquid solid interface. In this period, mass transfer by convection and diffusion prevails. Now this is important. ये चीज मेरे को थोड़ी सी बतानी है कि पहले डिफिकल्ट होगा, क्योंकि एक जब तक कोई इक्विलिब्रियम स्टैब्लिश नहीं होता दो फेज के बीच में, तब तक एक्सट्रैक्शन नहीं होता। और इंटरमीडिएटरी जो फेज है वो ऐसा फेज है जिसमें मास ट्रांसफर मतलब डिसोल्यूशन, मास जा रहा है एक फेज से दूसरे फेज में। इट अकर्स बाय डिफ्यूजन टू सम एक्सटेंट बिकॉज दैट इज गोइंग टू अकर फाइनली, एंड कन्वेक्शन। एंड व्हाट इज कन्वेक्शन? Convection is essentially the movement caused within a fluid or a sample by the tendency of, say, hotter and therefore less dense material to rise. That means that temperature rises, and colder where it is denser material, जो कि अंदर होगा, सैंपल के अंदर होगा. So denser material under the influence of gravity, that means there will be a temperature difference in the external sample, surface of the sample, and internal surface sample. This difference in the temperature under the influence of gravity results in heat transfer. इस कंडीशन पे जब अंदर का कुछ पोर्शन ठंडा है और बाहर का कुछ रिलेटिवली गर्म है, अंडर द इन्फ्लुएंस ऑफ ग्रेविटी, तब जो हीट ट्रांसफर होता है उस हीट ट्रांसफर को हम कहते हैं कन्वेक्शन, और उसी से मास ट्रांसफर होता है क्योंकि दे आर वर्किंग इन द सेम डायरेक्शन. सो दैट इज कन्वेक्शन. डिफ्यूजन मतलब, कोई मुझे बता सकता है व्हाट इज डिफ्यूजन इन सिंपल टर्म्स?
Something which is goes from high to low.
Okay, high concentration to lower concentration. Correct.
From higher concentration to low.
Correct. You are right. So this is what happens. मतलब जो सॉल्वेंट है उसमें कुछ नहीं है, जो सॉलिड है उसमें सब कुछ है. तो डिफ्यूजन वहां से इस तरफ होना शुरू करेगा, सॉल्वेंट में आने की कोशिश करेगा. And in the last phase, the solute must overcome the interaction, then bind it to the matrix and diffuse into the extraction solvent. अब क्या होता है कि इसमें एक है ना फ्रिक्शन होता है, जब वो आना चाहता है और नहीं आने मिल रहा है, दिस प्रोसेस गोज ऑन. और जब ये प्रोसेस होता है अंदर, तो उससे फ्रिक्शन से हीट जनरेट होती है और वो हीट डिफ्यूजन को प्रमोट करती है, और उससे रिएक्शन स्पीड अप होता है. सो दीज आर few fundamental steps extraction in the extraction using MAE. और इसके बाद एक चीज, ये इसमें भी आप लिख सकते हो कि जैसे लिखा है कि which is the correct order of extraction in microwave assisted extraction, which is the correct order in microwave extraction assisted extraction. तो उसमें हम ऑप्शन कैसे देंगे? इक्विलिब्रियम फेज, इंटरमीडिएट ट्रांजिशन फेज एंड द डिफ्यूजन फेज. एक ये ऑर्डर हुआ, पहले ये, फिर ये, फिर ये. दूसरे में हम देंगे इंटरमीडिएटरी ट्रांजिशन, फिर इक्विलिब्रियम फेज और फिर डिफ्यूजन फेज. चौथे में हम देंगे डिफ्यूजन फेज, इंटरमीडिएटरी ट्रांजिशन या इक्विलिब्रियम फेज. हेलो, फिर से शांति हो गई। अरे लिखा कि नहीं लिखा?
हाँ सर, लिख लिया।
वेरी गुड, वेरी गुड। बड़े बड़े एफिशिएंट हो लिखने में, बोलने में एफिशिएंट नहीं हो, लिखने में तो एफिशिएंट हो। गुड, चलो अच्छी बात है। तो देखो एक और सवाल बन गया, ये सब किसके लिए हो रहा है भैया? ये तुम्हारे लिए हो रहा है। मैं तो बता रहा हूँ कि अगर मुझे इस तरीके से एमएससी में दे दिया जाए कि भैया हर यूनिट में 40-50, तो मैं तो एक हफ्ते में इसको पढ़ के मैं तो बोलूँ एग्जाम ले लो भैया, क्योंकि सब कुछ आ जाएगा। इट इज दैट सिंपल, अगर तुम इसमें थोड़ा फोकस रहोगे तो। आई एम ट्राइंग टू मेक बेसिकली थिंग्स सिंपलर फॉर यू because I understand the situation now. It is very bad as of now, and how people are, surviving, and you people have to study, and though you don't have anything else to do as of now, but of course there may be some problem at your place, I don't know, so you will be dealing with those as well, and you need to study as well, and back to back everything is happening. So that is why I feel that I should make things simple for you, and that is why I am a little bit more concerned that you should understand this. And if you can understand this during lecture, I think that would be easier for you as well as for me. अब इसमें एक और भी जो मैकेनिज्म्स हैं वो चीज मैं आपको जस्ट ये स्लाइड में थोड़ा सा और आपको टाइम लेके आपको बता देता हूँ, बिकॉज दिस इज इम्पोर्टेंट, otherwise most of the things I have already explained. In microwave heat transfer एनर्जी ट्रांसफर अकर्स बाय टू मैकेनिज्म। जो एनर्जी जो ट्रांसफर होती है, हीट एनर्जी जो ट्रांसफर होती है, वो बाय टू मैकेनिज्म, डाइपोल रोटेशन एंड आयनिक कंडक्शन। अब मैं डायरेक्टली इस पे आता हूं, व्हाट इज आयनिक कंडक्शन? जो आयन से उसका एक होता है ना चार्ज, वो पॉजिटिव होगा वो नेगेटिव की तरफ जाएगा, तो वो जो मूवमेंट होता है, वो जो कंडक्शन होता है आयंस का, दैट इज नोन एज आयनिक कंडक्शन. Ionic conduction is the electrophoretic migration of ions when an electromagnetic field, just like microwave, is applied, and the resistance of the solution to this flow of ions results in friction that heats the solution. अब जब जैसे मैंने बताया कि नेचुरली एक चीज सॉलिड में थी, वो अचानक से लिक्विड में आ गई, मतलब सोल्यूशन में आ गई, और उसको चलना भी है, तो सोल्यूशन क्या करेगा? फ्रीडम उसको देगा नहीं, तो फ्रीडम नहीं देगा तो फ्रिक्शन होगा, जब फ्रिक्शन होगा उससे हीट जनरेट होगी. ये आयनिक कंडक्शन हुआ. मतलब जो एनर्जी ट्रांसफर हो रहा है, जो हीट जनरेट हो रही है, दैट इज बिकॉज ऑफ आयनिक कंडक्शन. टू मैकेनिज्म्स. एंड सेकंड इज डाइपोल रोटेशन. ये डाइपोल रोटेशन डायरेक्टली कंसर्न विद सॉल्वेंट. हर सॉल्वेंट का एक डाइपोल मोमेंट होता है, एक डाइलेक्ट्रिक कांस्टेंट होता है, उसमें एक डाइपोल होता है. जब एनर्जी उस पर आती है तो वो अपना ऐसा ओरिएंट करता है अपने आप को कि वो उससे एनर्जी ले पाए. ऐसा नहीं कि एनर्जी आ रही है वो ले नहीं पा रहा है. सो इट ट्राइज टू ओरिएंट इटसेल्फ such that it aligns with the dipole of the energy which is incident, and therefore it can take up energy. ये चीज समझ में आई? ये दो चीज बहुत इंपॉर्टेंट है कि कैसे एनर्जी ट्रांसफर होता है इन माइक्रोवेव एक्सट्रैक्शन. उसके बाद these are some of the steps which already I have explained to you most of the things, but this is written systematically for your understanding. Penetration of a solvent into the solid matrix, solubilization, breaking down of components, then transport of solute out of the matrix. These are steps, phenomenological steps. Migration of extracted solid from external surface solid into the bulk solution. Movement of the extract with respect to the solid where friction occurs. Separation and discharge of the extracting solid. So these are some of the steps, I mean, one by one, which occurs, which have been broken down into small steps of extraction. बट द लास्ट स्लाइड जो है ये बहुत इंपॉर्टेंट स्लाइड है. इस पर मैं थोड़ा सा बताना चाहूँगा कि जैसे मैंने बात की थी कि सॉल्वेंट का रोल बहुत ज़्यादा होता है माइक्रोवेव एक्सट्रैक्शन में, और उसको देखते हुए कुछ सॉल्वेंट्स की कुछ प्रॉपर्टीज़ होती हैं जो कि ऐसी होनी चाहिए कि वो हीट ले सके और माइक्रोवेव एक्सट्रैक्शन में असिस्टेड वो पार्ट ले सके, उसको असिस्ट कर सके. ऐसे सॉल्वेंट्स सेलेक्ट किए जाते हैं. हर कोई सॉल्वेंट नहीं कर पाता. तो सबसे पहला जो क्राइटेरिया वो ये है कि डाइलेक्ट्रिक कांस्टेंट आपने देखा है, इट इज डायरेक्टली रिलेटेड टू डाइपोल मोमेंट और डाइपोल ऑफ एनी गिवन सॉल्वेंट. आप ये देख रहे हो ये टेबल में डाइलेक्ट्रिक कांस्टेंट जिसका ज्यादा होता है ना, वो ज्यादा हीट लेने के लिए क्षमता रखता है. The tendency to extract the energy incident on these solvents is more with increasing dielectric constant. और अगर आप ये टेबल देख रहे हो तो इसमें आपको लगेगा वाटर which is 78.3, much higher than the rest. So one can very well say that dielectric constant is one of the defining parameter which assists in micro extraction. इसी के बाद एक कॉलम देखो जिसमें लिखा है dissipator factor. Dissipation factor is equally important when you compare solvents for their efficiency. जितना ज्यादा डिसिपेशन फैक्टर होगा उतनी ज्यादा सॉल्वेंट की इफिशिएंसी होगी. इससे दो बात निकल के आई. सॉल्वेंट में दो प्रॉपर्टीज होनी चाहिए. एनर्जी लेने की टेंडेंसी जो उस पर इंसिडेंट हुई है, और एनर्जी लेने के बाद देने की इफिशिएंसी सैंपल को. अगर ले लिया और दे नहीं पाया तो इट डजंट मेक मच सेंस. सो डिसिपेशन फैक्टर शुड बी मोर फॉर ग्रेटर एफिशिएंसी. अब अगर आप वाटर का देखो, डिसिपेटर फैक्टर इज 1570 only, but when you look at this you find 4 times more almost. Propanol, methanol, even acetone, even ethyl acetate, these solvents have much higher dissipation factor. So water, because of high dielectric constant, it can take up energy but it cannot give energy. So we need a solvent which can take up substantially and then very efficiently give that energy. So in that case, we generally work with methanol, for example. Here propanol would be a better solvent, even acetone in some of the cases. Hexane doesn't give anything because unfortunately it doesn't take anything, and therefore it is considered as microwave transparent. You understand? Hello.
Yes,
चलो एक जने तो बोले. आप लोग खाना वाना कुछ खा के तो आए हो ना, कि सुबह सुबह मैंने बिठा दिया और बैठ गए? अच्छा. तो ये चीज थी डायरेक्ट्रिक कांस्टेंट और डिसिपेशन फैक्टर. अब बॉइलिंग पॉइंट अगर इट्स एन एवरेज काइंड ऑफ अ थिंग, इट इज फाइन. बॉइलिंग पॉइंट से डायरेक्टली रिलेशन माइक्रोवेव एक्सट्रैक्शन में नहीं होता है, बट यस, if it is like 70 odd, it gives you a good extraction, but then we need to look at the other features as well. But viscosity अगर कम है, relatively कम है, तो it makes some sense. So basically the success of microwave assisted extraction depends upon the solvent system. The solvent which is more competent to extract, and that is one which has high dielectric constant and low dissipation factor, and preferably a medium viscosity or less viscosity. So that would be more useful, which heats up very fast. So temperature also would be a factor. Like for example, methanol it boils at 65 degrees centigrade. Propanol again 82 degrees centigrade. So there one can always use a mixture of these solvents so as to increase the efficiency of extraction. So this is what I wanted to speak on regarding the importance of solvents in micro assisted extraction. अच्छा इस पे कोई सवाल बन सकता है? चलो आपको I'll just wake you up. कोई नहीं बोलता है. हेलो.
हाँ सर.
हाँ
Yes,
कोई
sir.
इस पे हाँ
Yes, sir.
हाँ चलो भैया यस सर बोल रहे हो. ओके ओके. मैंने कहा कि कोई सवाल बना सकते हो क्या इससे? कोई सवाल बन सकता है इस स्लाइड में से? Which
So these
solvent property?
figures are meant for the like acetone is there, so the figures remains as per like constant is 20.7,
हाँ.
or it is dependent on like when we
No,
use it with different
no.
compounds.
It is constant. It is constant. It is constant.
It is constant. Okay.
It is determined 20 degrees centigrade. Yes, at 20 degrees centigrade, it is constant. These are all values determined at 20 degrees centigrade. Yes, and that is how we can compare. So now you can write a question like, uh, mm, which solvent property is useful in microwave assisted extraction? Which solvent property is useful in microwave assisted extraction? तो आप ऐसे लिख सकते हो high dielectric constant and high dissipator factor. High dielectric constant and high dissipator factor. Second could be low dielectric constant, high dissipator factor. तीसरा लिख सकते हो high dielectric constant, low dissipator factor. और चौथा लिख दो identical dielectric constant and dissipator factor. हेलो लिख लिया?
हाँ सर.
चलो बढ़िया है. Okay, so you have 2-3 questions from this also. Actually I asked few others also in GIA to prepare. The moment I get those questions I'll be sharing that with you also. Okay, so don't worry about questions you will be getting a big list of questions for this unit, maybe more than 50. So okay, so this was all about microwave assisted extraction, which I just explained. अब एक और चीज है, जस्ट मैं एक ये लास्ट चीज बता देता हूँ आज के लिए. So because I feel के I should not be forcing things on you, because you may be in a different state of mind. So अब ये है कि protein precipitation, this is not exactly an extraction, but yes, it helps in extraction. It is not this process, it is precipitation, but then we say it is extraction. By precipitating something, it helps in extraction. That is how protein precipitation, and as the name implies, it is used for proteins only. Matlab, it is used to separate proteins from samples, and those samples would be biological samples. So this is a technique which we can say is a highly specific technique to precipitate protons in biological samples. Biological samples matlab whole blood, plasma, serum, urine, cerebrospinal fluids, tissues, so on and so forth. So this technique, protein precipitation, which assists in extraction of separating protons from biological samples, such as I said, whole blood, then plasma, serum, urine, tissues, cerebrospinal fluid, so on and so forth. There are many fluids, body fluids. So it is used for that purpose only. Now it cannot be used for extracting solid or something like that, because the things which are being used in this system are very, very simple. In this, it is a technique used to separate drug. Now this is important. It is used to separate drug from biological samples, biological fluids, by means of precipitating the proteins using organic solvent. This is one of the most simplest of techniques which is used to separate the proteins. Very simple, very quick, inexpensive technique to separate proteins from biological fluids or matrices using simple solvents such as acetonitrile, methanol, ethanol, or acidified solutions such as trifluoroacetic acid and perchloric acid. Very small amounts, very, very small amounts. I mean, 10 microliters, 20 microliters, 30 microliters of that order, volumes of that order. Acidified solutions such as trifluoroacetic acid and perchloric acids. So they basically are being added to the sample. So this is your sample. You add these solvents here, and then you centrifuge the sample. Centrifugation करोगे तो क्या होगा? Centrifuge करने के बाद जो precipitation है वो नीचे आके बैठ जाएगा. So you pipette 200 ml of plasma, for example. This is an example. Add approximately 2 to 3 times the precipitating agent, which is acetonitrile. Vortex to mix means you just vortex upside down, upside down, upside down. That is vortexing. And then centrifuge. And then collect the supernatant. Supernatant matlab ye upar wala. When you remove this, what you get is precipitates of protein at the bottom. So this is a quick and simple technique which uses organic solvents, sometimes addition of acids, as I said, and you can have this is how you have, for example, drug and protein in a sample, biological sample. When you add it, there will be a something which is not a clear solution. It will be sort of milky kind of a thing. Then you centrifuge it and it will precipitate the proteins, and then you separate it. So you have drug solution if there is drug inside your sample, inside your biological sample, it will be separated here. and the proteins remain at the bottom. So basically the principle is you change the dielectric constant of the medium. When you add solvent, organic solvent or an acid, you change the dielectric constant of the original sample and thereby you induce precipitation. You induce precipitation or salt induced precipitation of proteins. So whichever sample you have which contains proteins, for that, this is one of the most widely used process in biochemistry for separating proteins, but it is also used in chemistry, in clinical science, where we work with biological fluids, and it can readily separate proteins from biological fluids. So that is all you are supposed to know, understand. Okay, I can ask you one MCQ here. Which are the solvents? Which of the following is not the solvent used for in protein precipitation? Which of the following solvent is not used in protein precipitation? Again, which of the following solvents is not used in protein precipitation? अब इसके options. पहला लिखो एसिटोनाइट्राइल, दूसरा लिखो कार्बन टेट्राक्लोराइड, तीसरा लिखो मिथेनॉल, और चौथा लिखो ट्राइफ्लोरोएसिटिक एसिड. So your answer is
Trifluoroacetic acid.
no.
So there has to be
क्या बोल बताओ मैंने क्या बोल दी?
not used in protein precipitation.
हाँ.
Carbon tetrachloride.
Yes.
Carbon tetrachloride.
Correct, Rohan. Correct.
हाँ, trifluoride.
Correct. मैंने लिखा था नॉट. अगर मैं नॉट नहीं लिखता तो सभी है, मिथेनॉल भी है, एसीएन भी है, एसिटोनाइट्राइल भी है, ट्राइफ्लोरोएसिटिक एसिड भी है, इसलिए मैंने नॉट लिखा और नॉट लिख के कार्बन टेट्राक्लोराइड डाल दिया. सो आंसर इज कार्बन टेट्राक्लोराइड. तो ठीक है. I have about 27 slides more and I'll be taking around 2 more lectures for completing this unit. So next week, definitely I'll be completing with unit 1 and then I'll be sharing this presentation with you. And in the subsequent weeks, I'll start with the other unit so that I finish well within time my syllabus, and then I can, we can move ahead with our internal exams as well. So चलो जाते जाते 41 तो हो गए. गुड. थोड़े बड़े हैं. So अगर कुछ पूछना है तो यू आर मोस्ट वेलकम. और आपको कुछ ऐसा कुछ बताना है या कुछ करना है तो प्लीज फ्रॉम माय साइड यू आर फ्री. You can switch on your cameras and then you can speak as Richa mentioned, so I have no issues with that. फिर से कोई नहीं बोलता है. सब थक गए हैं लगता है. यस. कौन बोला? देवर्षि. ओके देवर्षि, बोलिए देवर्षि भैया. चलिए आप ही बोलिए.
सर ये एक्सट्रैक्शन टॉपिक है.
आपकी आवाज थोड़ी सी कट गई, फिर से कैन यू रिपीट?
सर आई वांटेड टू आस्क दैट ये एक्सट्रैक्शन वाला टॉपिक है वो गैरी डी ग्रिशन से प्रेफर करे या डैनियल हैरिस से?
दोनों दोनों करना, दोनों करना।
दोनों से?
हाँ, ये दोनों से करना, क्योंकि डेनियल हैरिस में अच्छा है, लेकिन क्या सब चीज नहीं मिल पाएगी। जिस तरीके से जो मैं सिलेबस में रखा गया है और जो चीज जिस तरीके से मैं प्रेजेंट कर रहा हूँ या दिखा रहा हूँ, ये सारी चीज आपको एक बुक में नहीं मिल पाएंगी, ये मैं आपको अभी से बता दूँ। हाँ, 70-80% यू विल गेट। लाइक फॉर एग्जाम्पल क्लाउड पॉइंट एक्सट्रैक्शन जो आपके सिलेबस में है, जिसको मैंने अलग से उसका काफी लंबा बनाया है, मैंने 10-12 स्लाइड्स का है, वो आपको नहीं मिल पाएगा ये दोनों बुक्स में। माइक्रोवेव एक्सिस्टेड एक्सट्रैक्शन का भी आपको इतना डिटेल नहीं मिल पाएगा ये दोनों बुक्स में। एंड रेस्ट ऑफ द थिंग्स आई थिंक यू विल गेट, रेस्ट ऑफ द थिंग्स यू विल गेट। सो दैट इज वाई मैंने ये जो भी स्लाइड्स थी इसको काफी डिटेल बनाया है, and so as to make you understand each and every aspects of these two extraction process. ये बहुत important है, ये क्योंकि ग्रीन अप्रोच में ये कंट्रीब्यूट करती हैं इन एनालिटिकल साइंसेस। तो ये दोनों टेक्निक्स बहुत इंपॉर्टेंट है, माइक्रो असिस्टेंट एक्सट्रैक्शन एंड क्लाउड पॉइंट एक्सट्रैक्शन, विच आई विल बी टेकिंग अप एट द एंड ऑफ दिस। सो लेकिन आप पढ़ते रहिए, एंड if you come across any query or something, I'm there to help you. That will never be an issue.
Okay sir, thank you.
Thank you, Devarshi. Okay, if no one has any more questions, then I'll just stop here. I don't want to move ahead now, because now the next thing is solid phase extraction, for which I need to be a little bit more patient in telling you, and I feel that you are tired now. So thank you everyone. I'll stop the recording. I have already taken your attendance.